Alright guys, welcome to lesson 14 concept development video. We are going to be working on dividing decimals with a single digit number, and we are going to have some remainders today. So today we're going to be using our place value chart to help us solve and divide, and then we're going to connect that to our standard algorithm method. So without further ado, let's get started. And let's go ahead and create a place value chart. And I'm going to put my decimal here. So that means ones, tens, tenths, hundredths, and thousandths. Perfect. Real quick, I'm going to copy this so that, let's make sure I do that. Right click, copy this, so that I can quickly make it again. So let me change colors so we can easily see what we're working with. And to start, let's divide 6 and 72 hundredths divided by 3. So first we're going to represent the number we're starting with, 6 and 72 hundredths. Let's use number disk, and I like to put them in rows of 5 so it's easy to count. So there's 6 ones, there's 7 tenths, so put 5 in a row, and then 2 more, and then 2 hundredths. And we're dividing that into 3 equal groups, so I'm going to give myself a workspace. Now the 3 groups I'm just going to do by dashes. Separate these groups by dashes, not dots, because I don't want them to get confused underneath. So I have my first group, I have my second group, and I have my third group. So now I can start dividing. And when we are dividing, we're passing them out to the groups equally. And if we have any extras remaining that cannot be equally distributed to the groups, then we regroup them to the smaller units. So to do that, we start in the largest place value because we can always decompose to smaller units to give us more to work with. So with ones, we have 6 ones and we have 3 groups. Already my brain's thinking, I think that will be equal. So there's 1, 2, 3, 4, 5, 6. Yep, so that was all of our ones, right? Now let's see our tenths. We have 7 tenths. So I know that there's going to be one regroup. 1, 2, 3. That was 1, 2, 3, 4, 5, 6. Cross them out. And there's 1 left over in the tenths place. So I'm going to take that 1/10 and decompose it into my hundredths. And I know that when I decompose to the right, because this is a base 10 system, that is 10 hundredths. Now, whoops. Oh, I switched to my typing tool somehow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then add that to my 2 that were already there. I should have 12. And let's distribute 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the answer for this, we just look at one of the groups, because we know that each group is equal, right? Because we just divided, so every group has the same amount. So there's 2 ones in each group, there's 2 tenths in each group, and then there's 4 hundredths in each group. So our answer for 6 and 72 hundredths is, divided by 3, is 2 and 24 hundredths. How do we check that? Well, we multiply. So I know 2 and 2, let me make this smaller so I can actually have some space. Well, I know that the quotient, the answer to the division, was 2 and 24 hundredths. So if I decompose it, I know that's 224 hundredths. I'm just changing it to unit form to make math easier. I'm going to multiply that by how many groups there were. Well, 3 times 4 is 12. 3 times 2 is 6, plus 1 is 7. 3 times 2 is 6. 672. I know those were hundredths. So that equals 6.72, which is exactly the right answer. Great. So let's try that again. This time we're going to show the long division or the standard algorithm alongside it. So we're going to do one step on the place value chart, and we're going to do that same step on the long division standard algorithm side. All right, so let's try the example of 5 16/100 divided by 4. All right, so let's get ourselves my place value chart down so we can work on that. I'm going to make it a little smaller. Right, perfect. And then I'm also going to put our problem into the long division symbol, or the long division standard algorithm method. So we're going to take our dividend, which is 5 16/100, and we put the dividend inside the den, some people like to say, to help them remember. Let me actually move that down because that's going to be too high. So our dividend goes inside of the long division symbol, and our divisor, which is how many groups we're dividing into, goes on the outside. The quotient, the answer, is going to go up on the top. All the math that we need to do to solve it for long division goes underneath. So we use the underneath part of long division standard algorithm to help us solve the problem, just like we used the number disk over in the place value chart to help us solve the problem. Hold on, somebody's calling. Oh, it's Mrs. Jackson, so give me 1 second. All right, I'm back. So let me just undo my highlighting so we can start doing the math. So we're going to do one step on the place value chart, and then we're going to go ahead and do the steps over on the long division. Let me change colors to yellow. And so first thing before we even get started trying to solve, let's go ahead and set up the place value chart. I have 5 ones, 1, 2, 3, 4, 5, 1/10, and 6 hundredths. Whoops, I like to do 5 in a row, not 6. 5, and one more, 6. And we are working in 4 groups, so that's 1, that's 2, that's 3, and then the 4th one will be underneath it. So let me extend my place value chart. So I see my 1 group, 2 groups, 3 groups, and then my 4th group, right? So let me go ahead and change color again to green. And let's go ahead and start on the place value chart. And we're first going to divide. We're going to take our dividend. We got 5 ones, and we're going to put them evenly across 4 groups. We're going to distribute them equally across 4 groups. So let's go ahead and do that. 1, 2, 3, 4. Well, if I did one more, I wouldn't have enough to equally distribute to everybody. So that's where we stop, and now we have a remainder. So we're going to take that remainder and decompose it into our tenths. Well, we know that that's giving us 10 more of that group, so that's 5, 6, 7, 8, 9, 10. Now we have 11 in the tenths place. So let's remember that. We're going to press pause on our on the video, but we're going to just pause our thinking on the place value chart, and then come show that the same step over on the long division. So once again, we're taking 5 ones and we're dividing them into 4 equal groups. So this is where we have to think about our multiples of 4. Well, how many multiples of 4 can we take out of 5 equally? So can we take 4 out? The answer is yes. Can we take the next multiple of 4 out, which is 8? Can we take 8 away from 5? No. So we know that there's going to be 1 equally in each group. Oh, let me change color so it pops off a little bit. There's 1 equally in each group, right? And when we have 1 equally in each group of 4, how many did we pass out, or how many did we distribute equally? Well, if we looked over at the place value chart, we can see that we passed out all together across all 4 groups equally. We passed out 4 of them, because each group got one of them. So I'm going to go back, and now, so what do I have to do is we have to show that we've taken away those 4 and evenly distributed them. So we subtract it from 5, which leaves us with 1 remaining 1. And that's exactly what, I'm going to use my highlighter again. I'm going to go over to the place value. That's exactly that. We had 1 remaining 1 on the place value chart, and we decomposed it into the tenths. To show the decomposing over on our place value chart, or on our standard algorithm, we bring the tenth down to make our new number. Well, we just decomposed our 1s into tenths by bringing the 10th place down. So we're now working with 11 tenths. That's exactly what was up in our place value chart, right? 11 tenths. Okay, well, let's go back to the place value chart to distribute 11 tenths equally across 4 groups. So let's go ahead and start. 1, 2, 3, 4, 5, 6, 7, 8. That was 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. There should be 3 remaining because I cannot do another group of 4. So I need to regroup those 3 into the hundreds place. I'm not going to draw a 30 disc right now because that's going to be, it was even hard enough to see the 11 ones, right? So I'm just going to put a 30 over there. Let's pause our thinking on the place value chart and come represent that over on our standard algorithm. Now, remember when I said that we were working, all our numbers work down below? Well, we just showed our new number. So the number that we're dividing is always going to be getting lower and lower in the long division because of all the math that we do for it. So now we have to think of how many multiples of 4 can we take equally out of 11? Well, let's count by 4s, our multiples of 4. 4, 8, 12. Can we take 12 out? No, that's too many. So we have to go back to 4, 8. That was how many multiples of 4? Well, that was 2 multiples of 4. And 2 multiples of 4 gives us 8, right? And that's exactly how many we used distributed across 4 equal groups over in our place value chart. So we have to show that we've passed those out. So we subtract 8 from the 11, which gives us 3, which 3 tenths are remaining. And we look over at our place value chart. Again, I see the 3 tenths that were remaining, and we had to decompose those into hundreds. Well, we decompose those into hundreds on the standard algorithm by bringing down the next place value, which is hundredths. So we should be dealing with 36 hundredths. Well, 30 plus the 6 original number disk in our place value chart show the same exact number. Now, for me, I'm quickly going to shrink this so I have a little bit more room underneath it. So always make sure that you're giving yourself enough space to show your work. Now, over back to the place value chart. Oh, we have an announcement this morning for Mr. Toby. So let me get back to this. So we're in our hundreds place. We have 30 plus the original 6 in our hundreds place. So let's go ahead and distribute those equally through the place value chart. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Did it. Okay. So was there any remaining? No, because we used all 36. Okay, well, how many are equally in each group? Well, if I count what's in that place value chart, looks like there's 5 on the top row plus 4, so I know that's 9. Once again, that's why with our number disk, we like to be neat with them so we don't have to think as hard. So our answer should be 1, 1, looking at our place value chart, 1, 1, 2 tenths, 9 hundredths. Okay, well, let's go ahead and finish our standard algorithm side. So our new number that we're trying to divide is 36 thousandths. And we're trying to think about how many multiples of 4 can we take out of 36 equally. Well, if we count by our multiples of 4, 4, 8, 12, 16, 20, 24, 28, 32, 36. Ooh, 36. That's exactly the number I was looking for. We know that I just counted 9 multiples of 4. When I pass out 9 multiples of 4, I use exactly 36 of them as I showed in my place value chart. And so when I subtract that to show how many I passed out, I show that there is 0 remaining. And the great thing about the place value or the standard algorithm is everything's lined up in its places already. So the decimal just follows up and it lands itself right there. So our answer is exactly the same, and it's 1 and 29/100. All right, so you're going to be practicing that tomorrow with me if you're an alpha student, so you're watching this video before you come in. If you're an omega student, you're going to try to practice these skills with me on the problem set, and then you get a chance to watch the concept video before you come in on Friday. Distance learners, just keep doing what you've been doing and working so hard. Great job, guys.